am more. Oh, this meeting is being recorded.
Oh, sorry, I forgot to record it. I'm so sorry.
Got it. That's okay. No, we got rid of all of the sensitive information out first. Now we can start the recording. Perfect. Nobody knows those secrets. Okay, so, yeah. So I would like to actually hear from you. And again, we're gonna have to do this by, if you're on Zoom, first of all, so that I know you're paying attention, like raise your hand, push the little like Zoom little hand thing, so I know that it works. Perfect. I see one up. Good job, Benjamin. A couple of people, great. All right, so I'm going to ask you for feedback at various times, and if you can do that to let me know you're paying attention, that would be awesome. So here are our topics. I could talk about reverse engineering, just kind of like you've already had like a brief reverse engineering overview, so I don't think I'm going to do that. I'm not going to skip that topic unless you really want to, but I think you've probably already gotten some of that. I could talk about binary ninja, what differentiates it, how it works, what it currently does, what it currently doesn't do, where it's going. That's kind of one talk. Or I could talk about intermediate languages, and kind of we can dig into the weeds in terms of like how binary ninja does its analysis and compare it to intermediate languages between other tools. And that's kind of like in the weeds, but very technical. Or I could just talk about some capture the flag stuff that has happened over the years, and we've got a bunch of different capture the flag stories. So those are your three choices. You've got binary ninja, intermediate languages, and capture the flag. And I won't bias you. It's audience participation, but I do get to break ties. So make noise if you want to hear about binary ninja, or wave your hand in Zoom. Nobody wants to.
No hands.
Oh, okay, a couple. There's one in Zoom. Okay. Make noise if you would like to hear about intermediate languages.
I got 3 hands.
Okay.
4.
Okay.
5.
4, 5, the hardcore.
Yeah.
Ooh, man, the brave. I like it. Now, how many people total do we have in the room?
Around like 12.
12. Okay.
Yeah.
And how many people want to hear about capture the flag?
Yeah, CTFs.
Yeah. Like 6.
CTFs.
Okay, so you know what? Maybe we'll split the difference, and I'll do a little bit of both then. I told you I get to break ties. So a little bit more maybe on CTF, but we're also going to cover some. But this actually means I'm not going to use this VM at all. So hold on, let me get rid of this VM, and we'll switch up a little bit. If I can find my slides quickly. Okay, so first I'm going to do like an abbreviated version of a talk on intermediate languages called Intermediate Languages All the Way Down. And I have given this talk several times, which is part of why I ask, because if people have already seen it or heard it, I don't want to bore them too much. But we're gonna split this with some with some of the CTF stuff. So first, yeah, boring. Okay, this is good though. I want to know, again, real quick, show of hands or make some noise, who has done binary reverse engineering?
Decent amount of noise. Yep.
Okay. Who has used a decompiler?
Woo.
Okay. Who has written any kind of code, like plugins for automation or reverse engineering, like written like IDA or Binja or Git or any kind of like automation, Anger, R2?
Probably only John.
Yeah, that's all right. And who here has used like an intermediate language or an intermediate representation before?
Scott and John.
Scott and John, great. Okay, now actually, this is a trick question. Anyone that said they've used a decompiler, you've probably used an intermediate language. You just didn't know it, right? So that's kind of what we're going for here. Okay, and yeah, some other stuff. Okay, so first of all, what is binary analysis, right? If you have already had compilers, you probably know more about this than I do. This is just like a really simplistic overview of like when you take source code. Typically, I'm looking at like something like C, but this generally applies to most of the languages that are compiled to native architectures. It's going to get parsed into an AST. It'll go through one or more intermediate representations, and then out comes machine code, and that's what a compiler does. Decompilation or lifting is the opposite. It's taking binary code, machine code, and turning it back into this intermediate representation. And I'm going to use where's my other slide? There we go. I'm going to use intermediate representation and intermediate language interchangeably. Some people don't. Some people would distinguish them and say that like there's some actual properties of like a language versus a representation doesn't actually have to meet formal, whatever. I use interchangeably, most of the people do. but not everyone. So if you hear me switching back and forth, that's just how I'm going to use it. All right. So the goal, again, an image representation is just sort of between this high-level source code and an architecture-specific CPU instruction set, right? It's something kind of like in between, halfway there. It's like opcodes, but for a CPU that doesn't really exist, and they're not necessarily like exactly concrete values. Sometimes they're more symbolic, or they have other kind of properties. But it's used to model and represent in between like a high-level source code and a native bytecode. All right, and I like questions. So if you have a question, yell out, and Gabriella can repeat it if I can't hear it, or just in general, if you're on Slack, unmute and talk. I like interruptions. So static versus dynamic analysis, right? Like I promised I wasn't gonna do like, well, I didn't really promise this, but I didn't say we're gonna do the intro to reverse engineering, but this is an important concept. So static analysis is what? Oh yeah, I'm gonna ask questions too. You'll have to pay attention. What is static analysis?
Cole?
Come on.
You read code to figure out what it does, looking at control flow graphs and assembly, that sort of thing.
So Cole said is when you read code and you look through control flow graphs to see what it does.
Yeah, what's the primary distinction between static and dynamic analysis? Like what's like the 2-word summary, or like the shortest summary you could think of, like what's dynamic and what's static?
Dynamic can change around.
Nick says dynamic can change around.
Close, can change around, but like specifically, there's like one word I'm looking for here.
Ben says execution.
Yes. Execution. Is it running? Is the code running? So it's dynamic analysis if we run the code, and it's static analysis if we just sort of look at it. That's usually kind of how we would distinguish between these two, right? So we'd say using a debugger, using GDB or WinDBG, that's dynamic analysis. And opening a binary ninja and IDA and Ghidra by default is static analysis. Now, the line gets blurred, right? Because Ghidra, IDA, and binary ninja all have debuggers, and WinDBG and every other static analysis or every other debugger also will give you like disassembly and some level of static analysis, although usually much less than a tool like IDA or Ghidra or binary ninja. So it's not like this is a hard and fast line, but generally speaking, I'm going to be focusing on static for these purposes. And I'm going to skip this topic, and compilers make things difficult, and there's a bunch of undecidable problems and things that actually make binary analysis super hard that people tend to overlook. If you ever want to do research in this domain, come and talk to me later. But like I tend to put it this way if I'm kind of being succinct, which is deciding what bytes in a binary file are executable and what are not purely statically is very hard. In fact, it's impossible. It's undecidable. You cannot prove, it's actually equivalent to the halting problem. It's been shown to be, you cannot even prove if like this piece of memory, is this data? Is this a butterfly? Is this a piece of data? Is this a piece of code? You actually can't tell perfectly, but you can approximate, right? You can get reasonably good answers some of the time. So we are gonna try to make these approximations, and we're gonna use intermediate languages to create some sort of representation and analysis to let us answer questions about binaries. All right, I already answered that one. These are actually all synonyms. You're technically bitcode, VM opcodes, pcode. Pcode is used by Ghidra to describe their intermediate language, but it actually predates them. The original work on the original academic research on decompilation that informed both IDA and Ghidra was by Dr. Christine de Cifuentes, I think, I forget. She's I think Australian. I forget what university it came out of, and that paperwork in particular, or is it that one or the one that came after? You coined the term P-code to mean like portable code, actually, not pseudocode, which is be it also a perfectly acceptable abbreviation in this context. But it was meant to mean portable code, kind of like you think like the JVM, right? So the Java Virtual Machine is itself a form of portable opcodes. Now it actually gets run frequently, but really it is also kind of a form of an intermediate language or intermediate representation because it's not actually native. Ignoring Giselle, right, and hardware chips that have actually been made to run it after the fact, that's kind of like a fluke. And they're mostly gone now anyways. So most of those like don't actually run directly. They get interpreted or run by something else or transpiled or compiled or whatever. Okay. So here's like the short pitch, and I'm giving the faster version of this talk so I can get to the CTF talk too. But the short pitch is reverse engineering is how we figure out how software works. If you have a piece of software, reverse engineering is how you figure out how it works. Compilers when they compile code, all modern compilers use at least one or multiple intermediate languages. And therefore, intermediate languages should be how we do reverse engineering. We should go backwards using intermediate languages. And all the modern compilers do. Every modern compiler uses some form of intermediate languages, and that's kind of what we're going to talk about. Like, what are these things doing? How are they doing it? What are the differences between them? Okay, so first, why would we even use an intermediate language in the first place? Like, why don't we just like analyze the code and like figure it out, turn it back into source code? Like, why do you have to go through, or for that matter, even why do compilers go through an intermediate language, right? It's the same question because we have this intermediate state to help us do this kind of analysis and optimizations. I also talk really fast, and I don't know how the audio is, so hopefully y'all can hear me, but if you can't, say something.
Yeah, you're on surround sound, so we're good.
Oh, the whole room. Okay. And I've got like the radio mic, so I can get real close and make weird noises. But okay. So here's one of the reasons that we use intermediate languages. It's way less work, right? If I want to write code to analyze, like I want to build a plugin to decompile x86 or to do any kind of analysis in x86, I've got to handle, I mean, depending on how you count it, it's either like over 1,000 or like 4,000, depending on whether you count like different instruction encodings as unique instructions or just like variants on existing ones. Either way, there's a lot of opcodes, right? Like there's a lot of them. My favorite though is actually, this is an older version. I have a newer version of this chart, which has ARM64 in here. ARM64 has a lot of instructions too. I think it's actually like approaching 1,000 as well. And it's technically called a RISC. Like, come on guys, reduced instruction set, like 1,000 opcodes? You're kidding yourselves. Like it's not reduced at all. Like it hasn't been for a while. But technically, we say like CISC and RISC, and there's these different kind of like families of architectures. But yeah, it's really, those are kind of meaningless distinctions. But what is true though is that you notice that most of like the very, very small, with the exception of something like a RISC-V, most of the intermediate representations are much simpler, right? They have a much smaller number of instructions than the really complicated native CPU instructions. And there's some exceptions, but generally speaking, that holds true. Okay, another advantage why you'd use an intermediate language for both sides is that you can write your optimizations, you can write your decompilation, you can write your analysis and scripts on one thing, and then you translate. It's kind of like this unique spoken language. Like if everybody in the world speaks English, which is not true, I am American, we're not, come on, that ethnocentric, right? Like if everybody though spoke like one language, let's say, and then also spoke a bunch of other different languages, you would want to do most contracts and formal language in that one common language because like everybody could kind of interoperate that even if they had their own languages elsewhere. So that's kind of what an intermediate language is going to do too. We can write all our stuff to work on this intermediate language, and then we translate from all of these instruction sets into that intermediate language, and then we can do more analysis and things on top of that. So we write one level of translation for every architecture, and then we have a bunch of other plugins instead of like this matrix many-to-many of like every plugin and every architecture that we have to write this, exponential growth amount of code. And this is just sort of a code example I'm gonna skip for time reasons in terms of like somebody wrote a plugin for Binary Ninja when we first came out. It was like, oh, I want to like annotate syscalls and ARM, and we're like, that's cool, but that's like the IDA way. That's how you would do it on disassembly. Like here's the Binja way. Like, why should you care what register an argument is in? You should just ask the IL for what's the parameter to this call instruction and let it tell you that, right? And then that plugin, by the way, now works on every architecture, not just one, because you didn't hard code in registers. And also your plugin only worked on that one compiler because it happened to put the argument for the syscall at a fixed offset back from the syscall instruction. So like its ILs are sort of like the better way. All right. Now I'm gonna skip that. All right, so let's talk about like intermediate language design. Oh, also, I'm curious, how many people here have taken a compilers course?
One person.
One person. All right. Well, I never did. I actually was a math major. I graduated UF, and I was in the CS program as well, but I missed database design, compiler, and there was like one other class, like 3 classes to my undergrad computer science major. I took everything else, and then it was like, I don't really care about 2 undergraduate degrees. I'm just gonna be done with it. It's good enough. Just got the math. I was already working full time for the university anyways on the security team. But yeah, I'm very curious what y'all cover in your compilers course there, and how you kind of implement things. Do you just do like AST and like Lexiac, or how yeah? So catch me after, or tell John and ask him to like pass along or something, because I'm curious.
Yeah, he'll tell John.
That works. Thank you. Okay, so when you design an intermediate language, there's a lot of like trade-offs you can make, and the best example is let's say I had an intermediate language that had a one-to-one correspondence with all x86 instructions. So it's like literally just x86, right? So like for the crazy stuff like the x86 AES next round instruction, like you can do rounds of AES encryption in hardware on your x86 CPU with a single opcode. It's ridiculous, right? And if I had an intermediate language that mapped one-to-one to that, then like translating to that intermediate language would be trivial, right? Like ta-da. But like now I haven't really gained anything because now I have to translate all these other opcodes to the same intermediate language. And if I want to write my like optimization passes, my analysis on top of this intermediate language, I have to handle 1,000 opcodes. So it makes my analysis like really annoying. But it does make it really easy to read. Like that's super clean and readable, like lifting, because it just like translates right in. Like I don't have to like, you know, translate what was a one single x86 instruction into like 50 intermediate instructions. Like I can just kind of do this one-to-one. So like these are just trade-offs, and you have to sort of like optimize and choose like where are you going to be. But you go too far in one direction, you're going to have serious limitations on the other. And here's some other trade-offs in terms of like type information and flags and stuff like that. So here's an example. On the left is the x86 instruction test EAX. And on the right is, I have to check my speaker notes, I think it's real, which was an intermediate language from Zynamics, a company that was bought by Google a couple years ago. They're the makers of BinDiff and BinNavi. If y'all have heard of, anybody's heard of Halvar Flake, who actually has a company now called Optimize. It does like optimization stuff, but he's done a bunch of seminal research over the years on like, he's been on Project Zero, but a bunch of really interesting things, and built this tool called BinDiff. They use an intermediate language to do their BinDiffing, and that's it on the right. And it is abhorrent to read. Right? Like that is just unreadable, and that is one single x86 instruction. So if you want to translate a binary into that, like now the advantage though is there's only like 16, I think 12 to 16 instructions in real. So if you want to write like an emulator for it or any kind of code to like, assuming somebody's already done this translation for you, you could do like optimization analysis passes because there's only a few things you have to handle if you want to track data flow through it, for example, something like that. So like, you know, from writing it on an analysis perspective, there's some advantages to it, but it like hurts a lot on the effort it takes to create that lifting, to build that mapping for every x86 instruction. Good luck getting it accurate and correct. So that's kind of the trade-off there. On the other hand, this is how Ghidra does a floating point load, and that's pretty clean. Ghidra actually has Ghidra's P code is fairly well designed because it's a small number of opcodes, but I don't want to say they cheat, but they like overload, and like some of the opcodes are more sort of generic in what they can take. And so they just have like this, this floating point T is like a floating point constant of a 1. They can put any number though in there, right? It still counts as one instruction, even though it's able to load any number of constants, and that's pretty clean. Like that's because they had this concept of floating point built into their IL already, right? So they have that there. All right, so this is a list of all the ILs. This is not even like that complete of a list. I've actually got an updated version that has even more of these. It doesn't really matter. There's a lot of them, and so like, how would you use one? Why would you use one? What are the differences between them? Well, we'll talk about some of them. That also, these are just the ones that do LLVM IR. So how many people are familiar with like LLVM?
John and Scott.
I know y'all are. Oh, come on. No. If y'all are in a CS program, you ought to at least be aware of LLVM or Clang. And it's, who could tell me what that is? Like, what is LLVM or Clang? Not John. The two that raised your hand there first. Go ahead.
Clang is a compiler. I don't have
Correct. Yeah. Clang's a compiler. LLVM is just sort of like the whole tool chain around it. Like Clang is the compiler, but it's a piece of LLVM. The LLVM project technically includes like, you know, a linker, a loader, a libc. Actually, no, I think they don't have the libc yet. They just announced they're actually building a libc, I think. I forget. But they have like a lot of other components as a part of like the LLVM project, and then Clang is the compiler. That's one of the things that's in that product. And so LLVM IR is one of the intermediate languages that the LLVM project or the Clang uses when it's compiling. And there's a lot of really nice analysis passes. Like they do all sorts of optimizations. They have like bug checking passes. So if you compile your code with LLVM, you can be like, again, I'm gonna use them synonymously, compile your code with Clang or with LLVM, kind of mean the same thing. You could say, is my, oh, somebody in chat said something. I could bring up chat. Excellent, good, okay. You can like have it like do like all sorts of really advanced analysis and do bug finding and a lot of other stuff. That's really nice. You've got all this code. So a lot of people have tried to say, well, that's cool. When I'm compiling, I can run these analysis passes. But wouldn't it be cool if I could go the other way? If I could say, here's a binary, convert it back up into LLVM, and now run all my analysis passes. And so these people all tried, and it's a terrible idea. And I think they're wrong for having done so. We can talk about more if we have time, but I'm trying to be quick. Okay. So I'm going to talk about these 6 IRs because these are probably tools that you're all familiar with. Although actually that one in the bottom of the middle, I bet nobody recognizes. Anybody recognize that? I've already talked about it, but I didn't. So that's the Dynamics logo. Oh, someone's going to guess it. Sorry if I cut you off.
Oh no, sorry, I
That
said
is-
no.
Okay. Yeah, that's Dynamics. And I'm just going to talk about that because they have a really interesting IL. Okay, so LLVMR, I'm not going to go into the details. I think it's a bad idea to try to go directly to an LLVMR from native opcodes, but it's an interesting target like after you've translated or done some optimizations from a different IL, potentially, if you're going from native to that. So IDA Pro uses microcode internally, and there's actually another project that also uses something called microcode, so it's not even a unique name. But they have this concept of a maturity model. So yeah, so if you look here, this is the same opcode set. So this is the snip at the top is like 4 native instructions. And then the bottom is what those 4 instructions have lifted to. So you see it's already better than real. Like real, remember, had like just test was like a page full of code. And this is like 4 instructions to a page full of code. Like that's okay. That's usable. It's still not really readable. You're not going to like stare and actually understand what that thing means. But as they apply some optimizations, they do the initial lifting, they apply some optimizations, and then they get down to this, and then they turn it into like decompilation. And so that's how they get their decompiler. That's how the IDA decompiler works. And it is one of the best decompilers in the world. For x86 and ARM, I would say it's unparalleled. I say they have, like, generally speaking, the best decompilation for x86, x64, and ARM. Like, and I say this as a commercial competitor, right? I wish I could say that ours was better. But I don't think it is for the most part for like those architectures. I think for other architectures we can do better. And I think we have other things that we do, kind of better and differently, but they have great decompilation. And it's because they put a lot of work and their IR is actually tuned and designed a little bit for x86. They actually have to tweak and change their IR for different architectures. That's why they sell each architecture decompiler as a separate product. So because it takes more work and also maybe because it gets more money, so why wouldn't they? But when they did it, especially they were a monopoly, there was nobody else really around. So what are you gonna do? But like they've tuned it for each one. They've kind of like do a lot of like optimization work for each IR to each architecture, and then they have to kind of change it. And so that produces their decompilation. eSIL and Redair, I'm sorry if you're a fan, but I think eSIL is complete trash. I think Redair has some things that I like about it. Also some things that I don't like about it, but like in particular, the way that like this IR is bad for people and it's bad for computers. Like I'm okay with an IR that's good for computers and bad for people, like it's easy to parse. But this is like a string-based postfix notation. Maybe I actually haven't looked in a couple years at, so maybe they fixed it and changed it. So I would love to be wrong and this is better now. But it's pretty bad the last time I looked into it. P-code, I already said, I think it's pretty nice. Like it's actually fairly concise. Their IR, if you look from the native code, the IR that they produce is pretty clean and good. They also have this definition system called SLAY, and it compiles down these architectures, and they have a lot of different architectures. And Binary Ninja and Ghidra are both unique in that they implement decompilers on top of these agnostic IRs. And so any architecture that they support, they can decompile. So IDA, right, has to like adjust their IR for every architecture and like tweak and tune the system. Whereas both Ghidra and Binja, you can implement a new architecture, add it yourself, and then the system will go off and decompile it for you and do a bunch of other analysis on top of it. So that's the other advantage there. Real, I already said, oh, okay, 17 instructions. I was wrong in the total instruction count. It's got 17, but it is very, very small total number of instructions. Okay, yeah, so basically, there's a lot of differences between IRs. There's advantages and disadvantages. So when we were building Binary Ninja, we're like, let's just have all the IRs. So we made this many IRs, and this is the old version of the slide deck where it says they were under development. This was actually released last year. So all 10 of these are in the current version of Binary Ninja. You can like open up Binary Ninja and see these different ILs, and they have kind of different purposes. And there's a whole bunch of reasons why for that I'm not going to get into. Are there any questions? Because I've been talking for too long.
Nope, none here.
I mean, I'm just going to wait till I get one, though. That way I know people are paying attention. It could be any question. It could be unrelated.
I have a question.
Cole
Yes.
has a question.
What's the point of having so many intermediate languages?
That's a great question. So, I assume you're meaning for binary ninja and not for the industry as a whole, correct? But I do have an answer for both.
Specifically, yes.
Yeah, so for binary ninja. Okay, that's a great question. So assembly, obviously, well, so actually I lied earlier, so we have 10. We have a complicated number, but we have a lot. Assembly is not really the IL, right? Lifted IL is what you would write if you want to add support for new architecture to binary ninja. It's like the lowest level. And lifted IL and low level IL actually share mostly the same opcodes. They're not really all that different. There's just a little bit of transformation that goes on internally. This is probably equivalent to IDA's maturity model where they just optimize, but it's really the same instruction set. So those really aren't any different. SSA forms are, does anybody know what SSA stands for? Does John know what SSA stands for? Have you ever touched that, John?
Single static assignment.
Good job. Who answered that? Was it John?
Yeah, it was John.
I wasn't sure if you'd actually done anything with that, but yes, absolutely. Now, what does it mean?
What does it mean?
That everything is assigned once and you have like the C nodes and stuff. I don't really know. I've only vaguely touched it. Thank you.
No, you nailed it. You nailed it. That's exactly right. Single static assignment is a thing used in program analysis, and program analysis is like the science of like writing code to analyze code, right? So people who are doing correctness proofs or writing like things to try to find vulnerabilities in software or to like optimize software. So like most of the exact same techniques used as a compiler designer to make your code faster or to like, figure out when you can eliminate memory checks because an operation's safe and therefore it can be a faster execution if you remove the check in these particular cases. But if you remove them too aggressively, you're exposing yourself to vulnerabilities. Like there's all sorts of really interesting research that goes into play. Program analysis people have kind of invented all sorts of stuff. One of them is called single static assignment. And the short summary is, actually, let me show you. So this is Binary Ninja, and I'm going to open up a binary, and how's the font? How big is my screen? Should I make the font bigger?
Oh yeah, a little bit bigger.
What is Ninja?
Some cool guy built this really nice feature where I can update the font size in both the UI and the call graph, and so it's really nice. So if you're into fonts, Binja has the best fonts.
Is that what your font's using?
Yeah. It's honestly a better feature than Stack feature.
Ooh, I don't know about that. StackView is pretty great. It's pretty great. We do get a lot of people are pretty hyped about StackView lately. Okay, viewable. That better?
Yep.
Okay, so I'm gonna pull up the medium level IL linear view. Okay, so this is medium level IL instructions, and actually this well, I think I have it in like the slide deck too here, but like actual samples. Yeah. So here's another way of looking at it. Here's assembly. Like here's disassembly. And then if I hit the right key, it was flashing kind of weird. Okay, let's try again. Here's disassembly. Here is low-level IL. And I'm gonna go back and forth. You can see it's kind of like the same shape. You'll see like the same constants and strings. And like it's just kind of turning into like pseudocode, right? So like push RBP, like push RBP. RBP equals RSP. Like, yeah, it's gonna be a move, it's gonna be a move over here, but like it's just an assignment over here. Is that not refreshing for y'all? What is this doing? Sorry, I'm like fighting like screen sharing, not refreshing my screen. So this is like low level IL is just very close to the native assembly. And the reason, and now back to that question, which is a really long way of answering it, but I'll get there, is low level IL is a very close approximation for the native instructions. And so it's the most accurate lifting we can do, right? Every change that we make, everything that we lift, it's like very, very close. It's like the shortest distance between the sort of virtual pseudocode type thing and the actual native instructions. So we haven't done any kind of crazy optimizations or tried to like decompile. We haven't done any of that stuff yet. It's just very, very accurate. And there are times where you want that level of accuracy when you're kind of writing analysis. And it looks exactly like the x86. Like I said, it's just a little bit easier to understand. This crazy like SAR, D word, you don't have to know what that means. You can see here, it's gonna write into this location, reading this value and then shifting right to, right? So if you could, and there's still a couple things like the S and the .d. There's the only little complications of IL. And there's like, if you go to the user guide, docs.binary.ninja, there's like a how to read binary ninja IL that describes the little bit of specific stuff, but otherwise it's pretty generic. Okay, now this is medium level IL. Now wait a minute, now it's getting a little bit simpler. Now I don't see anything about the stack. There's no pushes and pops. It's just like some variables, some numbers and some go to, and there's like an if, and then Oh, that's like a print. That's like source code almost. Right now I've got like a call, and there's a string out here instead of in there, and then there's like this other thing. I don't know what's going on exactly there, but like it's starting to look like C. And then finally, high level IL. This is actually the whole function, and this is actually a really old version. It looks a lot better now. There's even some improvements here. All the strings are inlined, and a few other little changes have happened. But you can see the whole function now because we've gone higher and higher levels of abstraction. We're now like closer and closer to source code. We can see more and more of the program without looking at like individual instructions. So the generic answer to your question is that there are times where you want to do different types of analysis, right? And so I don't expect most of our users to ever look at an SSA view. It's not like you would use for manually reverse engineering. Usually when you're manually reverse engineering, you'll go between assembly, high-level IL, maybe you go down to medium-level IL. You may poke around in some of these ILs, but you would never look at like the crazy program analysis ones. And the reasons you might go down, like somebody asked earlier today, they're like, hey, I saw some like code branches that were eliminated in high-level IL. And we're like, yeah, it's because this system saw that as dead code. It did not see a reachable path. Its analysis concluded there's no possible way to reach that code branch. Like compilers do this. They'll put in dead code all the time, depending on their optimization levels. And they won't actually like, use the fact that they know that you can't go there to remove a code branch. And so high-level IL just like hides it from you. And somebody's like, well, what if I want to see it? We're like, no problem. Go to medium-level IL. It doesn't do that optimization for you. It's like a lower level of analysis. It's like, oh, okay. So just know if you want to check for stuff, you can go check there. But like higher level is still going to be way more concise and readable and kind of more abstract. And it's going to simplify all the control flow and stuff. So that is the explanation. Like that's the main reason why. And now specifically the SSA forms, what I came over here for, that's like we all hide those under this advanced forms. And again, there's actually this mapped medium and these other ones. They're used partially internally, but they're actually also somewhat useful. So like this SSA form, this gets crazy because you see like Greek symbols. You're like, why is there, oh wait, where's the, come on, tell me I've got a fee in here somewhere. How do I not have a fee? Are you kidding me? Oh, let me do a different battery. This one should have it. There we go. Here's a fee. Like there's like Greek fees and stuff in here. That can get kind of hairy looking. It's not, but I'm not gonna go into it today because I want to save some time for CTF stuff. So that's the answer to that question. Good question though. And then the other question is like, why does the industry as a whole have so many? And that's what this slide is. It's like the XKCD. There's 14 competing standards. It's ridiculous. We're going to fix this. We're going to make the one standard that everyone's going to use. Now there's 15 competing standards, right? So that's kind of how we have so many ILs. In fact, somebody recently told me, a friend, she was making a joke. She was like, well, you can't get a PhD on updating an existing IL, right? Like people are incentivized to sort of make new ILs for like academic research. And it's sadly kind of true. There is definitely a trend in the academic research community to like, it's got to be new and different or else you can't get past your review committee. And so there is a little bit of that truth to that bitter statement as well too. So that's part of why there's like all these different ILs. And part of it's just different needs, different people, different like, architecture supported or language bindings. There's a lot of other practical ones. I think I even have, yeah, some of those over here. Okay, so that's that. Any questions about intermediate languages? That's all the bonus slides. All right, skip past you.
Wait, sorry, keep going.
Why is it that researchers, the research committee doesn't like when you try to improve on an existing
IL.
Yeah, on an existing IL.
Yeah, so it's not that the research community as a whole doesn't like improvements to things. It's that for you to be published as an academic in a famous paper or in to get published research, to actually mainly in conferences, right? To be accepted at a conference and at a prestigious peer-reviewed journal and stuff like that, your work has to be considered like new and interesting and groundbreaking. And like I added this small feature to an existing intermediate language is way less compelling than all the other intermediate languages are bad. I had to make a brand new one with all these crazy advanced features and do this other cool stuff. And then your thing bit rots and then you're just on the pile of other things being, trashed a few years later. So this is a little bit of just a criticism of like the academic research community and how they disincentivize important incremental improvement and they incentivize like major big things that actually aren't practical or can't really be applied. Like you have a harder time getting published and accepted. And you can ask any PhD student this, and the vast majority are like, oh yeah, no, like I couldn't get that past my committee. I've got to get like something new and different and crazy. It's kind of like a known sort of, it's just a structural flaw in the way that the academic community does research. There's other advantages to being in academic communities versus other places.
We had a question
What's
that he
Do you have any
said,
examples in mind?
do you have any examples in mind?
No, because they never make it through. That's the point, right? Well, so there is a little bit of a trend now to do, what are they called? Like state of the union, state of knowledge. There's like a particular name for a type of paper that all it does is review all the different things out there and just kind of summarize and explain all the different approaches. Systemization of knowledge, I think. Does somebody else have a?
Yeah, Ben just said that.
Yeah. So like it started to become a little more popular, I feel like, in the last couple of years, which I think is a good trend and sort of like counter to that, the existing like it's got to be new and great, and you can actually get accepted if all you do is just a really good job summarizing the strengths and weaknesses of a lot of different things that are already out there. Because people are realizing like we have all these like things out there that claim to be the greatest, but like half of them are like not really applicable to real world problems. Why aren't they being used out? Like if some of this research was like so groundbreaking, they would all be in commercial products and like people would be like building crazy stuff on top of it. But like usually it like, oh, it works great until you apply it to like Visual Studio. And Visual Studio as the compiler just does things that break a lot of these kind of analysis or weird stuff happens. So like a specific example, I will say, here's another good counterpoint. Anger actually is a little bit of a counterpoint to my argument, because it's served as a good base lately for a lot of research where people will take anger and they'll go do some research on top of it and extend it. So that trend has maybe shifted a little bit, but I still see a lot of people doing stuff in research that I was like, I mean, that's cool, but like Binary Ninja already does that. Why don't you just build on top of Binary Ninja and do something better and different and advanced instead of like just sort of recreating what's already out there? Is that a better answer?
Yep. Thank you.
We can talk more in person later, maybe. One day I'll make it up there again. Okay. CTF talk?
CTF talk, guys? Yep.
Okay. So I have some slides somewhere, and I gotta like dig them up here, but I might just kind of babble for a little bit and answer questions and talk about stuff. I actually started playing CTF at UF. Actually, I think I have some slides online right here if I can find them. Well, so I gave an old talk at DEF CON with some of the stuff, which I don't recommend watching because I just don't like watching any of my old videos. But it talked about like the state of DEF CON CTF back in like 2011. And there was some fun, like dirty tricks and interesting things that happened. Where's my other one? No, this one, A Brief History of CTF, yeah. Here? Come on, where did I put it? Here we go. It was there. I just did the subfolder. Okay. So I think everybody here, I'm not actually running the challenge. This is real relevant. We're doing this. I'm assuming you all have played or heard of CTF. I would think we can get past that, right? And this as well too. We're going to skip like there's blue team, red team, full spectrum. You can call it a lot of different names. But one of the, like my first start, I first played DEF CON CTF in 2000. Well, so technically I first played in 2001. I actually went to DEF CON like whenever that was in 2001 and played like it was back when you could like just show up. You could like walk in the room and be like, I'm here to play DEF CON CTF, and they're like, cool, it's over there. And you'd like go in the other room in the Alexis Park Hotel, and you'd sit down and like maybe try to find a team, and maybe people would run up to you and literally physically steal your laptop or plug into your server. It was really ghetto and like shady, and there was all sorts of crazy stuff happening. It was super bad. And then so I went to like DEF CON this one time, and then a couple years later, a friend of mine went to DEF CON, and I had been at a conference with him, like a SANS conference or something on like network security, something not really like binary vulnerability research specific. And he ended up like winning, like there was like a solo round of DEF CON CTF that year. that he like won. And I was like, wait, dude, like you didn't know a bit from a byte. Like, I mean, he did, but like you were not a reverse engineer. You were not a vulnerability researcher. Like, what happened? He's like, well, I spent the last 6 months like studying the blade. And I was like, oh, okay. So if I just devote myself to your ways, will you show me the way? And he's like, yes, come join my team. So he formed a capture the flag team, and we called ourselves last place because we spelled up like 1 at ST place. And we're like, depending on how you read this, it's either first place or it's last place. And so we've hedged our bets. Like no matter where we end up, like we got this covered. Like we'll be good. And so it was myself, John Sawyer, Hank, who was another. He and I worked together back there at UF. He was there a couple of years after I was as well too, and along with several other kind of people that kind of came together around our team captain. And we played. We were like, okay, we're gonna like go play DEF CON CTF. So we get there, and they're like, here's your connection, and we're like, that's not a network plug. And they're like, no, that's a telephone wire. Here's your connection. And we're like, what? They're like, yeah, this is how you submit scores. Like you have a dial tone interface. So either get a phone or like script it up. So every flag that year was actually a number, and it was a DTMF. You had like there was an asterisk soft VoIP system, and you had to submit all of your flags via DTMF. You would literally like some teams actually did this. Like they would literally pick up the phone because they couldn't get a soft modem. They could actually submit the codes for themselves and like do all the AT commands, and they would submit the codes. It was on, I think, Solaris that year. It was kind of awful. It was actually kind of a terrible overall event, but there's a couple good guys on my team at reversing exploiting. We had a good kind of mix of people, and we ended up winning. It was a lot of fun, and that was like my first black badge back when it was easier to get such things. Anyway, all right. So here is actually so here we go. So 2001, again, I was at the Alexis Park. And like wandered in. This is I have I think in the slide notes on this one a link to like a Google sheet where I've been tracking this, and I've kind of been remiss about later years because I haven't been as active, unfortunately. So I would love more information and lots of extra stuff there. I try to talk to people and update it some, but obviously, or the overflow is now done. They've had their run of it, and you'll notice this trend, like this 4-year trend, other than the fact that legit BS because of egos, I would say, ran it for 5 years. It's like 4 years and you burn out, like you're done. Like that was the kind of the trend. The goons were kind of like the shifting crew. Ghetto hackers didn't last 4. Kenshota did 4. GD did 4, and legit BS is like, I have to do better than them. So they ran it for 5 years, and now or the overflow is done after their 4 years as well too. And so I'm curious to see who we get running DEF CON CTF. Also, I should also point out, like I'm kind of DEF CON focused in my sort of history here because I think it's just fun. There's a lot of stuff there. Obviously, there's all sorts of crazy cool stuff that happened at CTFs around the world. So I think it's a lot of fun. Any questions on this slide before I move on? This is kind of neat. The changes and things that didn't change, like how it was 32-bit x86 for like way too long. I'm not going to make you answer a question this time. I'm going to keep going. Go ahead. Sorry, I wasn't sure if I had a question. Okay, so this is Badger. Has anyone seen one of these before?
No.
So this was obviously, was it a yes?
Oh, no, sorry.
Oh, no worries. Okay, yeah. So this was DEF CON 22, and this was a really, really slick little challenge. So I felt bad because it ended up not like impacting the game as much. But this was it looked nowadays with like badge life at like DEF CON, it's like, yes, so what, another badge, right? But like this predated that. So this was, I gotta figure out how to navigate my own thing. So DEF CON 22, right? So we're looking at, this was 2017. So this is sort of like right before like badge life tends to like take off, and now it's just like everybody cool brings their own badge design that they've done. Like hardware badge design is their own thing. Like this was this really beautiful custom board. It actually had a custom RF chip, a custom like FPGA with dual like 2 virtual CPU cores made inside of this FPGA that they designed by hand, or they built their own like CPU design onto an FPGA essentially. I think they actually modified like an existing open source one for one of them. They had their own custom like RF, like sped spectrum, like RF signal hopping, like because DEF CON is awful on RF, right? Like you don't like just go and like, I'm gonna run a wireless network here. Like good luck with that. is it historically especially was just awful. And so this badge, like there was multiple interfaces. You could they actually had like this administrative interface over the RF link where they were sending around like information to all the badges that would automatically, like, it was like a mesh network too that would transmit and rebroadcast, and everyone would pass this data around, and then you would like tap into it and you could get access to this. And so you had to reverse engineer, I think it was an MSP 430 core that they were like emulating essentially, or like, like running on this custom FPGA build out that they had done. And just like the amount of effort that went into like this, it just looks like a badge, and you're like, nah, man, like this was some serious. Everybody nowadays just runs like the one chip, right? That's got like a whole Linux stack and 802.11 like stack already on it, and you're just like writing some little like LCD controller code kind of stuff. So this was seriously a ton of work. My team was the first one to find the vulnerability in it, and then we screwed it up so badly that we never got points on it. But we threw it against a team who was monitoring the network, and they're like, "Oh, I see the bug in their code," and they turned it around and actually owned it. No, I take that back. PPP actually had an exploit for this earlier, but there was an off by one in the like the network code, and as Team Zero, they were never able to actually get their traffic routed to anybody else, and so it was just really unfortunate. I think they ended up winning anyways, so it didn't impact it. Yeah, so 22. They won anyways. It didn't really matter in the end. It didn't affect it, but they were kind of bummed. They put a lot of work into it. Okay. Clemency is a nightmare. It's ridiculous. It's crazy architecture design just for DEF CON. I'm still think that was nuts. This was like the rise of CTFs over the years, right? Like, and I need to actually update this and come up with like the new total counts in CTF time, because it's kind of crazy just how many, like, we sort of take it for granted now. There were like 20 CTFs globally in 2011, right? That were on CTF time. So like this is and now there is literally like a CTF on average, there's one a day, I think, at one point, or one every other day or every two days. Like, you can play a CTF, and that's not even counting war games, right? Like the long running stuff. So it's kind of crazy just how much has changed. There's been all sorts of really fun like hacks of scoring infrastructure. That year with the PBX and the soft phone, one of the teams actually found like an admin interface to it via VoIP. They like brute forced like a pin and got into like this undocumented like admin menu, but they changed the IP address of the server and DOSed it. They just brought it down instead of actually like getting code execution. But that would have been beautiful. It would have been so nice if they would have actually done that. A bunch of stuff like things about like self-adjusting flags and other things I don't think are interesting. It is interesting though how the game has changed over the years, because like, I said, you used to just walk into DEF CON, you'd like plug in your laptop and you're like, I have a laptop, I'm ready for my server. And they're like, cool, run like a mail server, I guess. And so you would run your own mail server. And then like the Immunix team, which was like an early kind of SE Linux-ish thing. It was like a kind of secure, hardened Linux distribution, showed up and they're like, we are a commercial company selling like a lockdown Linux, and we've spent a bunch of time like locking this thing down. And people are like, well, that's kind of not fun. Like, I have a weekend, man. I'm not like here to like, find a flaw in your commercial, hardened Linux distribution in a thing you've specifically like locked down. And so that's when it started to change into like, okay, maybe we should actually give people custom services, and we should grade them on keeping the SLA up with those services. And so there's a lot of like Superman defenses that people have done. So there is a sort of interesting metagame that's really decreased the last few years as the game has become more brokered. And a lot of this can really be traced back to Cyber Grand Challenge, because when CGC ran at DEF CON, they also had their bot play in the finals, where it kind of got trounced. But like it did play, it had to be able to play, it had to be a broker game anyways, by which I mean, it wasn't just like you had a server and you just attacked their server, but specifically the infrastructure was being run for you. You as a competitor would say, here is my patch binary, please patch it, or here's my change. You would get network captures. You could attack kind of on the fly, however you wanted. But like, you didn't run your own server. It was being done for you. And so there's all sorts of stuff that fixed, which was nice, but I also kind of miss it. There was some really fun days of like ridiculously crazy tricks that people would run. Some of them were interesting and some of them were not. The non-interesting ones are like, I just ran netcat and I ran the same binary in a different box that didn't have the flags. Ta-da, no one can hack me. Like, we don't care, that's not interesting, right? There was semi-interesting ones, like people would run like a userland QEMU to like, intercept all activity out of that binary, and then catch it if it tried to access the flag file and deny it, which is like semi-clever. And that at least you could hack on because QEMU had a bunch of bugs and you could just like own it if you knew about it or wanted to. But like, yeah, so there's been all sorts of like questionable things that people did to like mitigate generically the services, as opposed to like patch the thing, throw the exploit. And so they've kind of solved that by this broker game. But there was some really fun and interesting shenanigans. In fact, one of them I don't remember if I mentioned here. And by the way, what time am I officially going till?
However long you like to stay or that you have time. Yeah, we're here.
Okay, I'll probably wrap up in 5 minutes just to keep it to like an hour, because my kids, my two younger kids are home alone, and they're very unlikely to burn the house down. Just super probably not. I should leave at some point. So one of the other, okay, one of my favorite actually, and I don't even think it's in these slides, was it used to be, again, you have a server that you're like on and people are attacking you. And it was just like, well, put a network firewall and block off all the people who aren't the game organizers, right? Like, come on, guys, are you bad at network defense or something? You know how firewalls work? And you couldn't do that initially at DEF CON because they use source routing. So it's essentially, it's like a NAT in reverse. So like, like network address translation, where you're inside your home network and everyone has 192.168, but when you go out on the internet, your IP address that your router has is your IP address, right? And so when you talk to like Google, like their server sees your router's IP address, not your IP. Well, source routing is essentially the opposite. It means everyone on the internet looks like your router to you. So you don't actually know, beyond your gateway, you don't actually see any IPs. Like it all comes from your gateway. And so it's like NAT in reverse. And so this was what they would turn on. And they would intentionally do this because that way you couldn't just be like, yeah, drop all from star dot whatever, and like, boom, like none of the attacker network can get to me. But the service checker, the poll bot that would scan my machine, that still gets let through. And so that like sort of solved it, except until it didn't. And this is... It's not, I think this is not only cool because the technology was developed, but because it was developed independently. So my team that I was on that year and one other team independently, I think not that year, but the next year, came up with the same technique that I've never seen published anywhere else in any literature, which is that basically there is a TCP timestamp field. So and some of this is TCP timestamp field existing has been hypothesized as different aspects of it. But every time you initiate a TCP connection to any host, there's a timestamp field as part of your TCP packet. And the actual field is not like an exact timestamp. It's really, you could think of it just as sort of a number that increases, but where that number starts at and the rate at which it increases is going to depend on the operating system and like when you actually turned your computer on. And so like all these things kind of determine what that number is. But if I have multiple connections over time, I can actually kind of get like a best fit line, and I can actually guess like, oh, look, you look like this same host because you're a Windows computer that has been up for 2 days or 1 day or 6 hours. And so Windows has a slope like this and you booted at this time. So on a medium-sized network, you can actually use this to de-anonymize hosts that are otherwise natted or source natted. And so this is like this really neat, interesting like network attack that was developed just for CTF, just so we could break the game. And we used it once successfully when another team actually brought ODay. So they were actually using a 0-day in the FreeBSD kernel, which actually I think there was some rumors that even maybe it overlapped with iOS. I want to say, let me see. Is that on here? Oh, come on, tell me I have it on here. I think I've got it here. Oh, yeah, so here's the TCP IP shenanigans, where I talked about that one. I made a little bit. I'm trying to find the. Yeah, I think this is the vulnerability that they were using. I'm not positive, but I think this was in FreeBSD, and it actually was in like Mac OS X maybe. It's not clear to me. Anyway, it's kind of like the lore of history. There's fun stuff. But they were actually using this as a privesc, and so that they would pop your box and then essentially become root. And they were even jumping out of their jail, and the organizers were not happy with this at all. And it was hilarious, but it was also annoying. ADC, whose picture is behind this that you can't see, was one of the people on the team that did that year. You can also see one of the PPP people wearing their jackets off to the side. But we actually deployed our like generic firewall filter and we blocked their team. So like once they started ODing us, we're like, well, we seem to have trouble identifying the score server. It was like changing the infrastructure they were using. We couldn't like plot out a map, but we knew who was throwing the 0-day. And so we just blocked that host and like poof, we disappeared from the network from them just by basically having a network proxy that would look at the TCP timestamp field. And if it fit that line and that curve that we knew them to be on, we'd be like, yeah, no, sorry, nobody home. We would block all their traffic. So that way we still let through other teams and we still let through the score server. All right. Yeah, that's probably... And there's a bunch of Pwnaventure stuff. How many people here have heard of Pwnaventure?
Scott.
I know.
Oh, Scott and John.
y'all gotta check out Pwnaventure. Just Google Pwn, P-W-N, Adventure. You'll probably actually just find the Live Overflow series on YouTube. So how many people know who Live Overflow is?
3 people now instead of 2.
I mean, come on, okay, we got one in Zoom too. All right, so a few more. Good. Okay, I would hope so. I would hope y'all know who Live Overflow is. If you don't, his videos are fantastic. You need to go watch them. He did a whole series on playing some of the Pwnaventure games, but this is like a series, and like this is a series of like hackable challenges that Rusty, one of my co-founders of Vector35, and a couple other people, but mostly Rusty. Like it's pretty much just him, built over the years, and like legit 3D multiplayer MMO, hundreds of people on like a live server sharded scalable environment, just for a weekend CTF. It was a little crazy and a little overkill. And like it started literally with just like this text adventure game, Choose Your Pwnaventure, and then it turned into like Pwnaventure 2, which was built on Unity, and then Pwnaventure 3, which apparently we're gonna see here, which was built onto Unreal, and like you actually had to like hack and cheat the game. There's some reverse engineering challenges, there was some game glitches, there was a whole bunch of stuff kind of built into it. And nowadays it seems a little bit more like common or achievable, but this was a pretty crazy thing at the time. That Rusty did that. So this is like when you get your first spell down there. There's a fire spell you get there. And then we went retro and built Pwnaventure Z, which is an NES game. It was hand-coded 6502 assembly. And actually I worked on that one a lot more with Peter. So it was me, Peter, and Rusty that worked on this one. And that was a lot of fun, like just building like an old school NES game. And it's actually like good enough as a game. We could have sold that game back in the day. Like it's actually a fun game. But it has just a ton of like CTF challenges all kind of baked into it. And so it's a lot of fun. Those are Pwnaventure Z is on GitHub. The other ones you can just search for Pwnaventure. Pwnaventure.com I think has 2 and 3 linked to it as well if you want more information to check those out. And so this is actually a speed run. We built Pwnaventure Z intentionally as kind of like an homage to the speedrunning community because they've been doing so much interesting work. It's like equivalent to like the best at like the security community. And this player is like, it looks like they're just playing the game in like the speedrun. They're not. This is not a map that's ever existed. Yeah, that's not where that map goes. They've literally corrupted the state of the game by like glitching it. And to even get here the way that they did, like that's not possible. They've just completely, you know, as all good like speedruns, like total corruption or aces or total control speedruns, any percent stuff does these days. And they beat him with the axe, which is like the basic weapon. It's hilarious to me. I love that. And there's an even faster speed run actually, where they literally glitch the game right from the load screen and walk off the map to win, which is pretty cool too. So that was a lot of fun because we had intended hacks and then they found even more. So that was really cool. All right, I'm really interested in a lot of like visualizations. How CTFs are visualized. It's kind of like a hobby, and I was involved in Cyber Challenge, which I mentioned earlier, which was a DARPA project for like machines kind of automate and play capture the flag. And we built a bunch of these visualizations. We actually worked with a video game company and designed like kind of like how these were going to work and represent. And the really interesting one is coming up. So I kind of want to. Oh no, that's the arena view. Does it show the other one? The film view I think is the most interesting. It actually shows like a 3D trace and execution of a binary in a space. I think there's a bunch of really interesting work there. It's just a lot of fun stuff. So here it is. This is the film view. This is the one I like. This is like actually legitimately useful for reverse engineering in my opinion. It's just kind of a headache to do the instrumentation, and it'd be fun to resurrect this tech at some point and do something interesting with it. So if you're looking for hobby projects or ideas for things, cool things to do, see me. All right. I don't remember what else I got. We're gonna call it a day, I think. Except for any questions that y'all have for me.
What are the best beginner CTFs that you recommend to start getting into it?
Deus X64 from Ret2, which just launched and uses Binary Ninja Cloud. So of course it's a shameless self-promotion, but they're also super smart. And honestly, I recommend like any of the high school CTFs tend to be pretty good. Seesaw's qualifier round tries to be a little bit more entry level, but it kind of ebbs and flows, depends on the year. Yeah, that's probably the main thing I would say are like war games or like doing like challenges from previous ones where you're not like as much of a time crunch, and do them together, like do them as a group. Get in the same room, do them as a group, mask up, it's pain, but like just like that's the best advice I give. Because for me, CTFs aren't fun at home in a room alone. Like it's just not. That's part of the reason why I don't CTF anymore, is because if I can't get into a room with a bunch of people solving stuff together, like it's a totally different feel. It's actually why I don't like DEF CON finals nearly as much as qualifiers. I mean, finals is fun because you want to win and it's like a different environment, it's competitive and you see your opponents and stuff. But like, I always had way more fun at quals because it was like a big group of people I'd be playing with, and not always, it was some small and big, but like playing with people, splitting up, working on challenges together, going off on your own, and kind of coming back, and like a kind of collaborative environment. That to me is what makes CTF really special, I feel like. And there is certainly value you can do it kind of by yourself, but it just, it's so much better with a team.
Thanks.
Mm-hmm. Any
I
other
have a
questions?
question.
Yep.
For someone who's never participated in a capture like flag event, how would you recommend like someone like myself get started in learning about it? Like any resources that you would recommend, or how would you recommend like if you could go back in time and like say to yourself like you didn't know anything, like how to get started?
Yeah, you just do it. Like you just do it, and you do it a lot. Like you're gonna fail. You're gonna not solve a single challenge for CTF. That's totally okay, right? Like you just kind of have to like it is like learning any skill. That you just, the more time you put into it, the better you're gonna get. Like there is no secret. There's no like this book, I mean, I can give you resources from here to Kingdom Come, but like ultimately, you've got to like go and once it like catches a hold of you and you're excited about it, like no one needs to tell you anything because you're going to go find the things that you care about. And I just hope you just do it as much as you can. Put the time into it. I will say though that like specialization is important. Like, so you kind of like can pick things you want to focus on. Do you want to like learn web security? Do you want to learn crypto? Do you want to learn? And so like a lot of people start with what they're naturally good at. Like if you've done more web programming or you've done more like whatever you maybe have more of a background in, like maybe start for the challenges that are like that and just focus on 100-point challenges for older CTFs in that area, or even go back to like these, even like the 500-point DEF CON challenges from 10 years ago would be like 200-point, 300-point challenges these days for the most part. Like, so just go, you can go to old challenges. If I can ever get some time, I need to reset up captf.com. I have a website that archives like the last 20 years worth of CTF challenges. It's currently sitting on my, hopefully it's still sitting in my Synology. Like I need to resurrect that. So like, just like doing it is the most important thing, and doing it with other people where they're going to kind of keep you like accountable and like make you kind of come out and keep doing it. And then like figure out the thing that you like and is fun for you and just study that. Yeah. Like if you have a specific question, like, okay, I want to do X, what resources should I look at? That's a little bit more achievable. And I can maybe give you a little bit more concrete stuff. Like if you want to just do reverse engineering, well, like you should do like reversing dot, is it KR? What's the other one? Pwnable.kr is the pwnable one. But is it reversing dot? Yeah, it is reversing.kr is one of them. There's a couple different ones. There's a whole bunch of different, like, again, the kind of war game sites where it's set up to like, you know, kind of, and if the hardest part is honestly is deciding like when to give up, because it's really important not to just be like try for 5 minutes and be like, oh, it's too hard. Like it's how you don't learn if you do that. But you also don't want to like spin your wheels too long. And so like there's this sweet spot where it's like, okay, I've struggled hard enough. I need to get some other advice, or I'm getting a little bit of a hint, or I'm gonna ask somebody this, and then I'm gonna go back and spin my wheels a little bit more. Because you never want to like burn yourself out. You don't want to like do it where it's just not fun. But you also don't want to just always just get the answer and just read write-ups. That won't actually help you. You need to just do it, and you need to struggle through it, and like that's how you get better and how you learn. So that's an important skill. It's just kind of generally knowing when to get it help and when not. And the best way to practice it is to do it. So like yeah, just do it. Go Nike. Anybody else?
Okay, speaking of Nikes, Jordan, John showed me the pictures. I know they
I
exist.
told you about it.
I know. John showed me the pictures. I know they exist. When are the Binja Nikes dropping on the corporate store?
I'm not wearing them today actually because they've gotten a little too run down. I don't know if those will ever show up on the company store. Those are kind of a one-off Nike My ID. They were good shoes though. They're at home still. I do still wear them. They say it says binary ninja on the heels. It's just like My ID on Nike. You could go and put like any text you wanted like on the heel of a couple of different shoes, and it's like normally you can get Nikes at a better deal. Like their list price is kind of expensive, so you're paying full list price, but like you get cool customization. You can choose exactly the colors and stuff. And yeah, so I was a little like all decked out. Like the joke is one day I'm gonna get binary ninja underwear, and then I'll have like everything ninja. But like right now I just have the hat on today. Nothing else.
All right, thanks, man.
Yeah, no worries. We do have shop.binary.ninja if y'all are interested in like stickers. Like $5 you can get a pack of stickers sent. Actually, usually we'll probably just send some up. If John doesn't already have a bunch, I just need to mail him some to distribute to y'all as well. But like there's other like hats and mugs and oh, there we go. See now, here we go. Now I'm on brand. Actually, the real one is this one right here.
Oh.
The whiskey glass. The problem is it wants to focus on my face.
Very clean.
Yeah, I don't think those are in the store, actually. All right, any last questions?
I don't think anything from here.
Cool. Oh, the Point Adventure Z is, though. You can actually buy an NES cartridge in our store. And it's only like $35 because it's like a pain for us to do, and I don't want to make it too cheap or I have to always be flashing them, so. All right, cool. Well, thanks, everybody, for having me. It was good to chat. Hopefully I'll see you all in person at some point. I like to come up and visit UF again, but I'll catch you later.
Yeah, for sure. Thank you so much for coming out and taking the time. Really appreciate it.
Thanks, everybody. Sweet. All right, bye-bye.
Have a good one. All right, thanks for coming, everybody. For those of you that are still hanging around, we appreciate you guys coming in the middle of what the start of midterms are. But if you haven't signed in, you can go to, I think it's like signin.ufsit.club if you missed the QR code. And we'll see you next week.